Okay, so what we will cover in this, that is address of a variable, pointer to a variable, pointer to arithmetic, pointer and functions argument, pointers and array. Uh, Turn off your mic first. Okay. Now, why basically we are discussing the pointer? What is the use of pointer? Then the important thing is any value can be accessible by their name or by their address. That is possible. Okay. Now, by their name, that is once we define the variable integer a, then a is the name of a variable. We can access the variable name using basically we can access the variable value in an expression, any of the expression, any of the functions for passing a value or something, right? Other than that, suppose I would like to access the variable value, or I would like to store the value of a variable, I can work with a pointer too. Now pointer is always talking about address. Likewise, suppose I am talking about Renoy, right? Then Renoy is the identity of him. Once I speak Renoy, I know that only Renoy will respond it, because Renoy is the identity name of the person. So same way, instead of that, suppose I'm saying that uh, who is living in Badaj, then this is the address, right? So again, Badaj is a big area, specific address, so and so building, so and so house, and so person. So that is the address basically. So here we are talking about, up to this point we have discussed about accessing a variable using by using the name only. Now we are discussing accessing the variable by their address. So that is a pointer. What is address? Each variable that is declared is stored in a memory. Since memory is indexed, each variable has an address, right? So once we define, we can say that uh, once we define the value, or sorry, variable, it may create one memory, right? So here the variable is integer I equal to 0. So I, by using this instruction, it will create one block. Okay, and it will create one block over here. Okay, and the name of this block, that is I. And of course, if the block is created somewhere in the memory, how it will be accessible? So it is accessible by their address. So address is always represented as 0x. Then after, suppose we are writing the 10 a, you know, this might be more useful for you. This is the address, because this is a part of EC, right? So this is the address of the block. Here the address is 10ab, right? So memory may be like at the time of designing a memory, or at the time of installing the operating system, it may understand that by what way, by what size we may identify the block. So this is the this is depend upon the block size. So here I have defined that 10ab is the address of this block, right? So it may be anything, the address may be anything, because it is handled by operating system itself. Same way, there must be a block for a variable C. Okay, then block for variable S, and block for variable L. Okay, then block for variable F, and this is for D. And each of this variable may have their own address space, right? So C allows the programmer to access access the variable, right? So suppose I am not interested to work this work with this variable using their address, but instead of that I can access the variable by the name only, that is I, C, S, L, F, B. That is possible. We have seen that, like we can directly write I, C, S, L, F, D. That is fine. Now we have one operator, unary operator, ampersand sign, right? That reads the address of something, gives the address of the operand variable. See the example here. So here, by looking this example, we can say that yes, ampersand I may allows us to print the address of variable. So where I is stored in a memory RAM, the address will be fetched and will be printed on the screen. As we are using percentage %f, we can use the percentage %h also. Okay, since constant and expression, this is again important, because we have other choice other than the variable also, that is there might be a constant available in our code and expression too. So constant and expression do not have a permanent storage, they do not have an address. So like we cannot write like that ampersand 1.0 ampersand d plus 6 are illegal. That is possible, no, that's not possible, because d plus 6 is again one expression, and it will not stored anywhere permanently. Okay, so this program was compiled by the GCC on a Linux machine, right? The previous code, right? So here variable table, variable I, C, S, L, F, D with this address 0B, 0x. 0x is required, I already told you. 0x shows that its address. So 0x, then B, F, 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 C 94, 93, 90, 80C, 88, 80. So these are the address space. Now suppose we are seeing that yes, how much bytes occupied by the we can say that the variable I may be occupied 2 bytes with respect to the NCC and Turbo C++ IDE concern. Suppose we are talking about I is a variable and that will be compiled using the GCC, it may holds 4 byte. So ultimately the thing is, it's all depend upon the compiler by which we are working on, right? So same way character may holds 1 byte, so accordingly this size may be occupied. Don't think that this is in sequence only, it's not like that. It may be anything, any random thing, and that will be handled by operating system itself, right? So we it's not our concern that where the actually variable is stored, but our concern is once the address space is allocated to the variable, then after suppose we would like to access the value of that variable, how this is possible, right? So here we have seen the code by which we are able to see the address of a variable and value of a variable. Fine. Okay, so pointed to variable. So ultimately we understand what is pointer. So pointer is one of the variable, and we are able to store the address of something. Here it's a pointer to variable, means we define the variable, we access the address of a variable with the help of a unary operator AND, right? Unary AND, and we use that address to store in a pointer, and then after we may work with the same block using a pointer. So that is why here the point is a pointer to variable. Here if a variable have address, can this be stored in the variables and manipulated with, right? This address have a new data types, derived data types called pointers. Pointers are declared as declared as one, that is a data type, right? So what the type of data we have, sorry, data type we have, it may be anything, any primary data type, user defined data type, or derived data type. So we may use it as a data type because it's a fundamental of a C language. For declaring any variable, here we are talking about a pointer variable. But declaring any variable, this is the syntax, data type and a name of a variable. Here it's a pointer variable, so star is required. Once we write a star before a variable name, now it's a pointer. So star variable name. In this example, one pointer variable has been declared as a p and it can store address of any integer variable. Okay, so integer I equal to 0, j equal to 1, k equal to 2, f equal to 3.0, 3 integer, 1 float. We define a pointer integer p, sorry, star p is equal to 0. Now what it will do, star p, see, initialization of this variable, that is fine, but so whenever we are writing this, it's a point to null. 0 may be used because see what pointer may holds, the address only, pointer never holds value, right? So whenever we are writing a syntax like that, star p equal to 0, that stands for it points to the null, means no address. P equal to ampersand k, that is integer, fine. So whatever the address of we can say that whatever let me create a block. Yes, suppose this is I, this is j, this is k, and in the same way we have a block for, yes, f also and p also even. Yes, p. Now just assume the address of variable I is 100, this is 150, 200, 300, and for a p let's go for the 1000, right? These are the address of a variable basically. Now whenever we are writing this syntax, p equal to ampersand k, so where k is stored, on address 200, means here 200 may be stored as a value of a pointer p. Okay, then what we are executing, printf p equal to percentage p, that is a p, backslash 3 that is for horizontal tab, star p equal to percentage d. Now please be remember, whenever we are accessing the pointer p, it's what p holds, address of k, so it's always written with address, right? And this is star p, so star p may always says that I want value stored on the odd address located, so or holding by the pointer p. So that means star p may says that yes, I want value stored on address 200 because 200 holds by the p, fine. So what we get, so here the value is 0 as we have initialized I equal to 0, j equal to 1, so this may have a value 1 and this is a 2. So from the first I know that p star p may print the address of variable k and star p equal to 2 because 200 on an address 200, what we have as a value that will be printed. Now second, that is what is j. So now I would like to change the value of a j, as this is the manipulation. So j is equal to star p. What is the star p? Star p is a 2, right? 2 plus 5, 7. 7 will be stored in a j. So now value of a j will be 7. And then after j equal to percentage d, star p equal to percentage d, j equal to j and star p. So j is a 7, and what is star p yet? Star p is still pointed to the variable k, that is a 2, no change. Now this is increment the pointer. We will see arithmetic of a pointer after this point. So star p is equal to star p plus I. That means star p, that is a 2, plus I. What is the value of I? That is a 0 right now. So 2 plus 0. Still we are on the same, that is a star p equal to, now see, this is a star p. So we are doing the manipulation over the value only. So 2, basically this is a 2, this is 0. So 2 plus 0, that is 2, and that will be stored on again the same location, star p, that is a store on the address 200. So value of k will be 2, no change. Now p equal to star p equal to star d. Now p and star p, again it will print the address. These two statement may have same result, right? Then after p equal to ampersand f, so p points to the variable f, that is 300, and printf percentage d, percentage p and d, p star p. So that will print the value of f, that is a 3.0, right? This holds 3.0, right? But whenever we execute this one, p equal to percentage p, it may print the address of variable f, and percentage d, that is used for integer. So instead of 3.0, it will print a 3. Now please be remember, normally whenever we are working in the way, don't try to assign a pointer to different types of variable. Like here we have a pointer to integer, and we are trying to assign or trying to point the block with float size or float data type. So don't do that. But as per the beginning, we can say that initially logic fine. Now the simplest operation is to get the address of a variable and store it in a pointer variable. So how can we store it? So see, here we have used that statement, that is a p equal to ampersand k, and here the same is used, p equal to ampersand k, p equal to ampersand f. Pointer p is declared to store an address of an integer variable. Assigning an address of a float variable p would cause a compiler warning of or error. Continuing in spite of a warning may result in a disaster. Like in certain case, here we are discussing, like suppose we are assigning any float variable to any integer, we know that it will truncate the value, but in that case value will be transferred to from one variable to another variable. We are not going to do anything with the existing variable, but in this case we are trying to access the variable by their address value. So suppose we are trying to access the variable by their address. Suppose we are trying to access the variable by that address, and the data type of that variable is different, it may cause warning or error depending upon the data type we are referring. Suppose it shows that warning, again the problem is containing in spite of a warning may result in a disaster, means we might get a wrong result too. So the thing is, don't try to assign different types of a variable to different types of a pointer. Okay, the value of a pointer p is the address of some integer variable. The value of an integer variable pointed to p can accessed by using a dereferencing operator star. Printf statement here prints the value of a p and that of star p. P is equal to, this is the address, 0xbffffc8c, and star p equal to 2. So star p is just like a k here. All the expressions where k can appear, star p also can j equal to say 7 and star p. We already seen this one, right? Sorry, here we already see that one, that value of j is 7 and that is a p still. Yes. uh, Now next, that is the dereferencing operator star p is not only used to get a value of the variable pointed by p, but also can be used to change the value of the value of that variable too. It is legal to use star p as a left side of an assignment operator. So like here we already use it, right? Star p on a left hand side of a assignment operator, we can assign the value to the star p. So that means now it will not change the value of a p, but it will change the value pointed by the pointer p. So specific address value will be changed, right? Uh, Here the example is a p equal to ampersand k, p is equal to percentage p star p is equal to percentage d. It will print the value of a p and star p. That means address of a k and value of a k. Then after we are using this, that is a value of a j and address of k, because we didn't change anything. Sorry, not address, but it will print the value of j and value of k, because star p is still point to the k, and star p is equal to star p plus I, that again change the value of a k only, and it will print the address of a k and value of k also, right? Now next, that is a pointer arithmetic. Now what is arithmetic? So as we have applied the arithmetic operation on the variable, that is j equal to a plus 2, j equal to, or c equal to a divided by b, or c equal to a plus b, a multiplication b, like that. So same way we can apply the pointer arithmetic. A simple arithmetic is allowed for the pointer. A pointer points a variable of a given type. When we add 1 to a pointer variable, it points to the next variable in the memory. Though it may not be the same type, right? Because now here the same variable rule will be applicable. Okay, so we can assign, sorry, here it points to the next variable in the memory, means it may increment the address, and whatever the value we have on that address, that will be accessible by the pointer only. They are not concerned about what the time of that particular block, because ultimately in a memory case we have an address only, and we can access the address and work with that particular address. Here p equal to p plus 1 would cause the value of a p to be added 4, which is size of integer. I already told you, as we are dealing with a GCC right now, 4 is a size of integer in case of a GCC compiler. But suppose we are dealing with a Turbo C++ IDE, it would be 2. So don't get confused about 1 and 4. The sense is, here it will increment the size of pointer. 1 means 1 size of pointer, 2 means 2 size of pointer, like that. Okay, integer I equal to 0, j equal to 1, k equal to 2, star p equal to 0, p equal to percent k p. So here they have taken this value of all. The output of the given code is value of k. What is the value of k? That is 8c, and value of k is 2. So p is equal to this and star p is this. Then after, by looking this syntax, p is equal to p plus 1. What we are trying to do? We are trying to increment the pointer variable, right? So 8c with 4. So c, d, e, f, 0. That is a 4 byte, right? Hexadecimal may have a digit with 0 to 9 and yes, A to F. So suppose we consider that yes, 8C, what a, this is the address of a P, and then after we execute the instruction, that is P is equal to P plus 1, right? What this statement will do, so what is the value of P first of all? That is 8C. 8C plus 1. P is a pointer to integer, and the size occupied by the integer in GCC, that is a 4. So add 4 in this address. Okay, so C. So what comes after C? That is a D, then E, then F. Once we reach to the F, it shows that it's the end of a hexadecimal value. That means the next would be 0, and the carry will be forwarded to the next. So this will be 0 and carry will be forwarded to the next, that is 8 will be replaced by 9 and this is a 0, right? So this is our next address, and we try to print the value of that. So what 90, what is see, address will be fine and star p may have a value that is 1. See, please be remember here, here j, with the help of a j we already have stored the value 1 in that. So don't think that like that after I j will be printed. That's not necessary. Suppose j is stored on this address, it will be fine, because normally what happen with this, that is this address will be automatically, like it's not necessary that the address may be stored in a sequence. So wherever it may find the space, it will be stored until or unless we are talking about array. In that case, it's a different case, like all the elements are stored in a sequence only. So fine, uh, basically with the help of this statement we can say that it may increment the value of a pointer p by the size 4 byte, and the next block would be 90. Again, don't think like that this block may be or must be a type of integer only. Whatever the type of this block may be, it will be accessible by this pointer, and it may store the data, it may fetch the data too with the help of a star p. Okay, then the next statement, that is p plus plus. This is a prefix, sorry, yes, postfix. This is a postfix increment. So of course p is equal to p plus 1, but as this is a p plus plus, so it will increment the value of a pointer p again. So after this 90 plus 4, that is a 94, that is the value of a I, this one, right, 94, and it will print the value star p. So as value holds by the I, that is a 0, it will be printed 0. And then after p equal to ampersand f, now see the address of f is 88. So it may write this, but whenever we are trying to access the value of that, we get a wrong answer. The reason is, as the value 3.0 will be, let me show you one thing. Suppose we are talking about 1 byte, right? So, or 2 byte, let's go for 2 byte. 1, 2, 3, 4, 5. Okay. Suppose we are talking about turbo C++, and suppose I am saying that 2 bytes required for the integer I, then for 1 byte there are 8 bits. So 3, 4, 5, 6, 7 and 8. 0, 1, again 1 byte 0 1 2 3 4 5 6 with the size 2 3 4 5 6 7 and 8, right? This is simple. Now important thing is, suppose I am writing I equal to I equal to 8. Okay, equal to 8. Okay, so from where it will be stored? So it may, the index may be start with here 0 1 2 3 4 5 up to 15. It's work like that, right? 15. Now the point is, suppose I would like to store the value 8. So where should I can say that put the value, that is a 1 0 0 and 0 for a I. Fine. So in the same way, suppose we are talking about float f. Again, the assignment would be starting from right to left. Now whenever we are accessing the block, now just understand, if I am accessing this address and it's represented this 2 byte, no problem with that. Here we are trying to access a big block with a small size. What happen? First 4 byte, which is I over here, this, sorry, which is integer over here, here pointer trying to access the integer block, as this is the pointer to integer. So what it will do, it may try to access the value from 88 to 92, because 88 80, sorry, not 92 but 88 to 9 10 a b, so 88b, right? However, so this is a 4 byte, basically 88 to 80b, that is 4 byte. Now suppose float may occupied 8 byte. What happen? C D E F, pointer may, sorry, float may holds the value in this particular portion, as the value is 3 only, the binary of a 3, that is 101, right? So 101 in a last byte. However, we are trying to access this one, that shows that this is a garbage value, right? So at this point, I am saying that don't worry about a garbage or a specific value, but try to understand, yes, this is a garbage value whenever we are trying to access different kinds of block with a different kinds of a pointer. Fine. So this is all about arithmetic of pointer. Now pointer and functions arguments. We have seen that since a and b are passed by value to swap one function, and the value of a and b in a main are not swapped. Here, with for this code, I can say that integer, we have taken two variable, integer I equal to 3, b equal to 5. So let's try to understand with, we can say that this particular, because you need to understand the address or memory structure for each variable at the time of dealing with a pointer. So this is my variable a, this is my variable 100, this is on address 200. Okay, now once I call this function swap1 ab, don't worry, we will discuss the function also, but it is quite easy to understand. Here we have defined the function void in swap1, integer a, integer b, integer temp is equal to two arguments, one is a 3, five. Okay, and integer temp, integer b, these are the three automatic of the function swap. So here there is a separate memory for variable a, variable b, and variable temp. Okay, and once we call this, yes, the 3 will be assigned to a. So now a is 3, value of b is 5 over here, no problem. And once we execute this statement, temp equal to a, yes, now 3 is stored in a temp also. And then after I can say that yes, a equal to b, so this will be removed, and once again value of a equal to b, so 5 will be stored over here, and b equal to 10, so 3 will be stored over here. Up to this step, it shows that value of a and b are swapped. But once the execution of this swap 1 is completed, and then after we are trying to print percentage d, and a and b, what is the value of a? What is the value of b? That is 3 and 5 only, no change at all. But instead of that, suppose we are calling the second, that is a swap2, another function. See, we are doing the same. Here we are passing the address of a and b. Here it may create again a two block with value pa, pb. Now what is the address of a? We are passing over here address of a and b. Address of a is 100, address of b is 200. That will be stored over here, as this is a pointer to integer. Yes, it may hold 200. Then after we take one more variable, that is a temp. Okay, now of course temp may have their own memory location too, but temp is equal to star pa. Star pa, what is the use of a dereferencing variable star? That is, with the help of that we are able to fetch the value located on the address of 100. So on address of 100 value located, there is a 3. So temp may have value 3. Okay, so this is 3. Then after star pa, star pb, what is the star pp? Pb, that is a value located on address 200, that is a 5, and star, so 5 will be stored, so store on the address of pa. Address of pa is 100, so this will be, we can say that the 3 will, this is 5 over here, and again star pb is equal to 10, so this will be destroyed, and temp, what is the value of temp? That is 3, so 3 will be stored over here. And then after we are trying to print the value of a and b, so what is the value of a? 5. What is the value of b? 3. Yes, we got the answer. So the result would be 3, 5 for the first one, swap 1, and 5 3 for the second one, right? So how pointer will work? It is indeed inconvenient that a function can return only one value. Yes, because this is the fundamental of the function. Whenever we are defining a function here, in this case, if you see that what is the return type of a function, that is a void, means this function doesn't return any value for both of these two functions, swap1 and swap2, both of these two with a return type with void. But it is indeed inconvenient that a function can return only one value. Consider a function for a bisection method. The function is expected to return a root of the function. Here we have made one function named getRoot, may accept four argument, one that is a double L, one a second that is a double R, third with the data type double and variable is a tall, fourth that is integer, next inter. So this is I can say that the prototype of a function shows that it may accept a 4 variable as an argument and may return the value of the type double. Fine. So return type of this function, that is double, as we expect that the function is expected to return a root of the function. So what is the root of a function? That is of type for double. So I define the function with a return type double. What would happen if the root is not bracketed in LR, right, interval? The function is still likely to return some value which is not required root. Ideally, that should be one more variable indicating the error. Okay, so that is integer star error. Now understand the default, this signature, suppose we are talking about this signature, ideally this is correct signature, but at the time of error it will not return anything as a double value, but instead of that we are interested to get the error message from the function. So we have defined one more argument of type integer, so integer to pointer, that may hold the integer code, right, and that will be used as a error message. Another and the last point of the pointer, that is a pointer and array. So an array name is a constant pointer. So if a is an array of 10 integer and pa is a pointer to integer variable, then pa is equal to ampersand a of 0. Pa equal to a, right? Array, sorry, are legal and same. So r b is equal to a of 5 and b is equal to star a plus 5. This will be fine because this shows that an array name is a constant pointer. First thing is, so if a is an array, here we already says that a is an array of 10 integer and pa is a pointer. So ampersand a of 0, what it says, it says that we have array with 10 variable, sorry, 10 element, 1 2 3 4 5 6 7 8 9 and 10. Now first element may have address value 100. Suppose we are working with a GCC, the next would be on 104 as 4 byte occupied by the integer in case of a GCC. This is for 8, this is for 12, then 16, then 20, 24, 28, 32, 36. So this block on address 136, right? It's simple, as it must be in sequential order only, as this is the array. Now suppose we assign pa equal to ampersand a of 0, then this is pa, this is a of 0, that is this block. Yes, so what is the address of this block? That is 100. So we can write 100 over here. Fine. Instead of this, suppose we are writing this syntax pa equal to a. What is a? This is whole block. And what is the address of this block? That is again initial address of the block, that is 100. So it's the same. So suppose we take one more variable b. Equal, suppose 0 1 2 3 4 5 to a of 5, that is this. Understand two things. One, arithmetic. So suppose we says that yes, a equal to, sorry, a plus 5, what this will do by default, suppose we are talking about this one, this is a kind of address structure. That means it may works as a pointer too. So a equal to a plus 5, or simple, not a equal to, just a plus 5. What is a? That is 100 plus what 5 will do. It may increment 5 element address. That means 120. So it shows that a plus 5 may result one referencing variable, right? Stop on this address, that is the 5. Legal and however, right, because this syntax is correct but this is wrong. Reason is we cannot constant structure, memory structure because what p holds any of the address, but we cannot change the address of the array with the help of this a declaration, assign the address of, or we can change the address of an array. That's not possible. Fine. So this is the end of end of a pointer. So any question?